In this video, we're going to study one of the very important topic in pre-calculus called the difference quotient. This is also useful in calculus. Useful in calculus. That is one of the reasons why we study this one. It's very useful. So to learn the idea, so let's consider the graph. So consider the graph. So we can look at this graph. So let's consider this one. So you have function like that. Now what we can do, we're going to pick a point. I'm going to say x here. And then the corresponding function value is fx. Next, what I'm going to do, I'm going to consider another point which is h distance away from x. So let's say I'm going to pick this point. So this is h distance away from x. So that we can call this x plus h, because h away from x. So that means now what we can do, we can evaluate the function at this point as well. So that's that point. So we have 2 points. We have one point here and another point there. And then we also going to evaluate the function at that point. So this is f x plus h. Good. The next thing is we're going to join these 2 points. So we draw a line that passes through these 2 points. So let's say so we draw a line that passes through these 2 points. This line is called the secant line. So it's called the secant line. Secant means cutting. So meaning cutting in Latin. So it's going to cut the graph. So and then we're going to also say this point, I'm going to call it P, and the other point up there I'm going to call it Q. So this graph is y equal fx. Now what we're going to do, we're going to find the slope of this line. So let's try to find the slope of this line. So to find the slope, what we can do, we can look at the corresponding right triangle here. So we can know difference in y. So if you look at the difference in y, so we can call the change in y direction. So that is simply f x plus h minus fx. So that's going to give you the difference in the y direction. To find the difference in the x direction, that we're going to call delta x, change in the x direction, let's call it delta x. So delta x equal, again, the difference is x plus h minus x. Actually, you can simplify this. You can see when you simplify, you're going to get h. So difference in x direction is easy, is h. Now what we can do, we can look at the slope of the secant line. So the slope of the secant line that is delta y over delta x. So let's plug in that. So that means it's going to be f x plus h minus fx. That's the top. The bottom is x plus h minus, it has to be correspond to the functions. So you can see this simplifies and you finally get, so this one is what we call the difference quotient. You can see that this is a difference and also quotient. So we call this is a difference quotient, but you can simplify this is fx plus h minus fx and divided by h, because x and x get cancelled. So this is what we call the difference quotient, and you can see that this is simply the slope of the secant line. So then let's try this as a definition. So the definition, the difference quotient, the difference quotient, difference, the difference quotient, difference quotient of a function, f at the point x is given by we can write this known as a dq, difference quotient of f. So this is how we write it. So it's simply given by f x plus h minus fx divided by h, and we assume that h not equal to 0. So this is the definition of the difference quotient. So it's a definition of the difference quotient. So now what we're gonna do, we're gonna find the difference quotient for several functions. So let's do this as an example. So let's say find the difference quotient for the functions. Find the difference quotient for the functions. So let's do multiple functions. For the functions, so the first one, let's say fx equal 3x minus 2. The second one, gx, let's do it 2x squared plus 3x minus 5. C, let's say kt, let's say square root t, because you can learn something interesting here. And the d, let's look at a quotient function. So I'm going to call px. Let's say 3 divided by x plus 2. So let's try to find the difference quotient for these 4 functions. So let's do one by one. So let's look at the first one. So the first one is fx equal 3x minus 2. So the difference quotient of f, by the definition, fx plus h minus fx over h. So we're going to plug in. If x plus h means you replace x by x plus h. So it is 3 x plus h minus 2. That's the first function. So I'm going to put another bracket around it, minus fx. fx is 3x minus 2. Since there are more than one term, I put a parenthesis around it, divided by h. So let's simplify this. So when you're going to simplify, so what you can do, you can distribute. So you're going to get 3x plus 3h minus 2 from the first one. From the second one, you get negative 3x and positive 2. Now you can see that many terms get cancelled and also divided by h. You can see that many terms get cancelled. So 3x cancel with 3x. And then negative 2 cancel with negative 2. And you can see that when I cancel, I'm going to cancel them in a different direction. Then you know what terms you cancel. So now you end up getting 3h over h. Now you're going to cancel h. If you cancel h, you simply end up getting 3. Get 3. So what is this? And you can see that this function represents the line y equal 3x minus 2. So this 3 is the slope of this line. That means that's exactly what we get. We get the slope of the line. So this is the slope of the line. Slope of the line. So that's a very important fact. So when you do the difference quotient, so you get a slope of a special line, and later we will know that this is the slope of the tangent line. So so let's look at the actual graph. So if you look at the graph of this function, so this is the straight line that passes through -2. So that's the line. So this passes through -2, and you know that this line has a slope m, which is equal to 3, and that's exactly what we get from the difference quotient for a line. So the slope of the line. Good. So there are some other observations as well, and you can see that. So one thing is, if it's a line, you get the slope of the line. The other thing is, you can see that the terms without h got cancelled. So that's something you observe. So you can see terms without h cancels out. So terms without an h cancels out. So that's always happen. So if there are terms without h, they can cancel out this one. So this is how you do the simplification. So let's look at the next one, part B. So B is a gx equal 2x squared plus 3x minus 5. So again, we use the definition. So the definition is dq g equal, so it's a g, so it's g x plus h minus gx divided by h, and when you plug in, so it is so wherever you see x, you can plug in x plus h, so it's a 2x plus h squared plus 3x plus h minus 5, and then minus gx. Gx is 2x squared plus 3x minus 5 divided by h. Now you can expand this. To expand, you have x plus h. So we're gonna remember one of the one of the formula. So we know that if we have a plus b squared, this is equals to a squared plus 2ab plus b squared. So we can use that relation here, that identity here. So that means this is simply going to be 2. This is x squared. First one is squared twice the product plus last one is squared. And then here we have 3x plus 3h minus 5. And if you distribute, you can see that negative 2x squared, negative 3x, and positive 5 divided by h. And you can see that again, all the terms without h get cancelled. So you can see 2x squared cancel with negative 2x squared. You just need to cancel x squared here, because then it cancels the whole term. And then 3x cancel with negative 3x. Negative 5 cancel with positive 5. And you can see that everything else has h, so they stays there. So now what you get is, when you distribute, you're going to get 4xh, and then 2h squared, and then 3h. So those are the terms that you end up getting. So this is h. Now what we normally do is we're going to pull h term out. So you're going to get 4x and then plus 2h plus 3 divided by h. Now you're going to cancel the h term. So once you cancel h term, you get 4x and then plus 3. I'm going to leave the h term at the end for a reason. So this is what you get as the difference quotient for a quadratic function. Now, so we have h term here. If you ignore the h term, that means this part is actually corresponding to the slope of the tangent line. So that's you're gonna learn in calculus. So this will correspond to the slope of the tangent line, this part. So that means when you set h equal to 0, or h is very, very small, then the rest of the part is corresponds to the slope of the tangent line. So this is slope of the tangent line, slope of the tangent, that you're gonna learn later. So this is in calculus 1. Okay. So let's look at actually the graph of this function. So if you graph this function, you can see this is very easy to graph. The reason is this is very easy to factor. So you can see that this kind of factor into 2x plus 5 and x minus 1. So you can factor into those two. So that means you're going to get the zeros. There are two zeros there. And using those two zeros, you can graph this function. So the graph gonna look like this because it has to pass through negative 5 half and 1. It's not in a scale. So it's gonna look like that. So it's not up to a scale. So this is 1. Now what we're gonna do, we can actually evaluate the slope at a point. So let's say you're gonna evaluate the slope at x equal negative x equal 1/2. X equal 1/2. That means you just need to plug in x equal 1/2 to this expression. So that means the slope at this point. So that means this is the tangent line. So if you draw the tangent line, it can look like this. It's a tangent line, and then you can see that. So the slope of this line, this tangent line is, if you plug in 1/2, you're gonna get 5. So 5 is the slope of this line. That again you're gonna learn in calculus. Good. Let's look at the next example. So at part C we have kt equal square root t. So again we use the definition. So the difference quotient of k equals, so the variable is t now, so it is k t plus h minus kt, that's going to give the difference in y direction, divided by h. So we're going to plug in. So k t plus h means replace t by t plus h. So you're going to get t plus h square root minus square root t divided by h. So now the question is how to simplify something like this. So the goal is to multiply by this by a special one. So we're going to multiply by this by a special one. What is that one is? We're going to multiply by the conjugate of the top. So we're going to multiply by that. So what's the conjugate? So replace the sign of this term, not inside, sign of this term. So that means it's a negative, so you can change to positive. So that means the conjugate is going to look like t plus h, no change here, and the minus become plus, and then square root 2 t divided by the same thing because this is 1. So this is what we call the conjugate plus t. So multiply by the conjugate. When you have square root, this is what we normally do. So this is called the conjugate. conjugate. So multiply by the conjugate. Now there's something interesting happens. So let's recall this formula. So when you multiply square root a minus square root b with square root a plus square root b. So what we do, these are the conjugates. What happened? You get the square of the first one and the square of the second one. And you can see when you distribute, all the other terms get cancelled and you only end up getting these two terms. Like square root a minus square root b, everything else get cancelled. So this is actually a result of this special one. So this is the difference of quotient. So we have x minus y. If you multiply with x plus y, you're going to get x squared minus y squared. So this is a sub case of that. So this will be useful. Yeah. So we use this result here. So this is a part of the difference quotient. So this is what we call the difference quotient. Difference quotient. Actually, the difference is not difference quotient. Difference of squares. Difference of squares. Good. Okay, now we can use this result. So that means, so you can apply this result to the top of the terms. So that means you can see one is a minus sign, one is a plus sign. So because of that, so you can see that. This has a minus sign, this has a plus sign, and then so this says that it is a minus b. So what is a minus b means? You're gonna get a means t plus h. A means t plus h. B means t. That's what you get. Divided by. So we have a little bit of extra term here. So we have h and also the new term t plus h plus square root t. So now we can see t and t get cancelled. So you're gonna get h over h times t plus h plus square root t. Now you can see, now you can cancel h and h. So it's going to cancel in two steps. And then finally you get 1 over t plus h square root t. So that is what you get as the difference quotient for a square root function. Now as before, we can also look at this as the slope of the tangent line. So if you look at the square root function, so what is the graph of square root function? So this is we can learn later. So this is the graph of the square root function. It's going to look like that. So it's going to look like this. So let's say you pick a value. For example, let's say you pick a value 1. So if you pick the value 1, say this t equal 1. So the slope of this tangent line, so if you graph the tangent, so it's gonna look like this. That's a tangent line. So we're gonna find the slope of that tangent line at this point, and you can see. So this is the graph of kt equal square root t. So you just plug in t equal 1, and then ignore ignore h. That means just consider h equals 0. And then plug in t equal 1, and then you're going to get the slope of the line. So that means you can see that it is simply equals to, the slope is simply equals to 1 over 2 times square root 1, which is 1/2. So we have a slope 1/2. So you can get it like that. So that you're going to do again in later in calculus 1. Okay, so that's about that. Let's do the last example. So as the next example, we have px equal 3 over x plus 2. So again, we use the definition. So the difference quotient of p equal p x plus h minus px divided by h. So we're going to plug in. So go to the function, replace x with x plus h. So it's going to be 3 over x plus h plus 2 minus px, which is 3 over x plus 2, actually x plus 2, and the whole thing divided by h. So now we have fractions on the top, so we're going to simplify this one, and then we're going to recall this shortcut. So let's say you have a over b minus c over d. It can be minus or plus, it doesn't really matter. So what we can do, we're going to multiply this as a cross multiplication. We can do maybe multiply a and d, so it is ad minus bc divided by bd. So we can use this shortcut when you have different denominators. AD minus BC divided by BD. If it's a plus sign, it's AD plus BC divided by BD. Okay, so yeah, so minus go with minus, plus go with plus. So depending on what sign. Okay, good. So it's a minus sign, so we're gonna minus. So let's do that now. Using a shortcut, we can write this one as 3 times the other denominator, and the 3 times the denominator of the top first one, and then the product of the denominators, which is x plus h plus 2 divide times x plus 2. Something you have to remember. Okay, and then we have a divided by h. We can write this one as multiplication of 1 over h. Division you can write as a multiplication of 1 over. That's how we did it. Okay, now we can simplify, and you can see the x gonna cancel with x because of the negative sign. Because if you distribute the negative sign, all the terms are negative, and then also we have a 2, and the other one are gonna be negative 2. So that means 2 gonna cancel with 2 because of the negative sign. So only terms that you end up getting is negative 3h on the top. So it's gonna be negative 3h divided by x plus h plus 2 times x plus 2 times 1 over h, and you can see now this h and h get cancelled. See, it's going to cancel the last step. Now we just write whatever we have, so you can see you only get negative 3 divided by x plus h plus 2 times x plus 2. So that is the difference quotient for the function px equal 3x plus 2. Again, so this is going to give you the slope of the tangent line. So let's look at the graph again. This is like extra step. We don't need that for this class, this pre-calculus. And also we can learn how to graph things like that in the later in this course. So so you will learn that when you have a plus like a term like that, what it's going to do is it's going to move the graph to the left by 2. So that means the graph of this function will look like this. So these are the axes. So it's going to move to the. So this graph has what we call the asymptotes. As again you will learn later. So there's asymptote at x equal negative 2. That's where the denominator becomes 0. So the graph gonna look like this. So it's gonna be going like that on this side. And then on this side it's gonna go like that. Doesn't look good. Yeah. It's gonna go like that, and then you can find the intercept. Just plug in x equals 0, so that means there's intercept at 3/2. So that's the graph. So that is negative 2. This is 0. Good. Now let's see we can find the slope at x equal negative 1 probably. That means what is the slope at this point? So this is negative 1. So that means the slope of the tangent line. So if you draw the tangent, so we can find the slope of this tangent line. So that's a tangent. at this point by ignoring h and plug in x equal -1, and when you do that, and you can see that you're going to get m equal -3, and you can see that that's exactly right. So that's how you do those problems. So next time I'm going to give you several practice problems for you to like train how to do these kind of problems. Now try these problems for extra practice, and you can find the answers in the description. So there are some hints for h and I. For h, you have to use the difference of cubes formula, and for I, you have to separate them into two.